Hello, you're welcome back. All right, still on static electricity. So we're going to continue from where we stopped. So here we are going to be looking at the principle of superposition of electric forces. All right. So when do we apply this principle, and what does this principle state? Now, the principle states that when you have more than one electric force acting on a particular charge, okay, the resultant electric force on that charge can actually be added, okay, vectorially, the same way you add vectors. Remember, in electric force is actually a vector quantity, and when you treated vectors in mechanics, you know very well that you can find the resultant of vectors. Are you okay? By actually adding it depending on the direction of the vectors you want to add. So the same is applicable to electric force. So when you have more than one of it acting on a charge, it can be added, okay, in a vector form, right? So now I have a question here. I was asked to evaluate the net force on the 1 microcoulomb. This is the charge of 1 microcoulomb. So what does that actually entails? It simply means that I have there are three charges here: 1 microcoulombs, 2 microcoulombs, and 3 microcoulombs, separated by this distance. 2 microcoulombs is separated from 1 microcoulomb by 10 cm, and you know very well, since 1 microcoulomb and 2 microcoulomb are all positive, there's going to be a force of repulsion. Okay, so let me call that force between 2 and 1 microcoulomb to be F12. Okay, so apart from the force between 1 and 2 microcoulomb, there's still going to be another force, okay, that exists between 1 microcoulombs and the other charge, okay, which is 3 microcoulomb. Let me call that F13. So that means this 1 microcoulombs right here, we express two forces. We experience two forces. One force due to the 2 microcoulombs, which are called F12, okay, force on 1 microcoulomb due to 2 microcoulombs, I call it F12, and this 1 microcoulomb we also experience another force due to the 3 microcoulomb, I call it F13. Okay, so now the total force on this 1 microcoulomb, okay, let me call that F1. The total force on this 1 microcoulomb is going to be the sum of the force, okay, due to 2 microcoulomb, that's F12, plus the force on 3 microcoulombs, I call that F13. Okay, so these are the, by the time you sum these forces, that will give you the total force on 1 microcoulomb, and that is the principle of superposition. The same way we add vectors. So let's get them one after the other. Let's start with the very first force. This is F12, the force on one uh, due to the 2 microcoulombs, right? Let's go. Of course, you know our formula. That's going to be equal to K. Then Q1, the charge of 1 microcoulombs. Q2, the charge of 2 microcoulombs, then divided by R12 square. Okay, R12 square, the distance between 1 and 2 microcoulombs. All right, so let's actually evaluate that. Of course, you know what we do. K is already 9 times 10 raised to the power of 9. Then multiply by the Q1, which of course is 1. Okay, we have to convert that is microcoulombs. That's 1 times 10 raised to the power of minus 6. Then times 2 times 10 raised to the power of minus 6. Then divided by the distance. The distance apart is 10 cm. Convert that to meter. That's going to give me 0.1. So I'm having 0.1 square. Okay, so let's proceed. F12 is going to be equal to, what do I have? Okay, let's do that. 9 times 2, that's 18. Okay, so I'm having 18. Then, of course, times 10 raised to the power of 9 minus 6 minus 3, that's minus 3. Of course, you know that already. Divided by 0.01. So if we divide 18 by 0.01, I'm going to have 1800. Okay, Yeah, 1800. Then now, if I should now multiply by 10 raised to power minus 3, that should give me 1.8 Newton. Okay, so you can confirm that with your calculator. Then let's get our F13. Of course, you know very well that our F13 is gonna be KQ1 Q2. All right, then divided by R13 R13 square. All right, so let's put those values. I'm having 9 times 10 raised to the power, raised to the power of 9, then times Q1, which of course is 9 times 10 raised to the power of minus 6, then times Q3. Now I have 3 times 10 raised to the power of minus 6, all divided by the distance. Now the distance from uh, Q3 to Q1, as you can see, is 30 cm, because this is 20 and this is 10. That makes it 30 cm, all right? And 30 cm converted to meter, that's gonna give me 0.3 square. All right, so let's do that. This is gonna be 9 times 3, that's gonna be 27. Okay, 27 times 10 raised to the power of minus 3, then divided by 0.09. Okay, so let's divide, of course, 27 by 0.09. What do we have? That's 300. So 300 divided by 1000, that should give me 0.3. So that's 0.3 Newton. So now let's finalize our answer. F1 now is going to be equal to F12, which was 1.8, plus F13, which is 0.3 K. So of course, if you should add this, you're gonna end up having 2.1 Newton. That is the resultant force on Q1. Okay, so I hope that is well understood. I will still bring more examples. I'll bring more example. Okay, this time around, let's look at a situation where you have uh, two forces acting on a charge. Okay, 1 microcoulomb on 1 microcoulomb, but this time around, the two forces are perpendicular. Of course, we know what we do when we have perpendicular vectors. So the force of 1 microcoulomb is due to 2 microcoulomb acting up here, okay, with a distance of 10 cm. Then another force here, plus 4 microcoulombs, okay, with a distance of 20 cm. So the question is, find the resultant force, okay, on this 1 microcoulomb. You know very well that the resultant force on this 1 microcoulomb cannot just be found by just adding the two forces, okay? Of course, let me call the force this one here. Let me call this, let's say this is charge Q1. This here right here is Q2. Q2 is equal to this, Q1 is equal to this, and this right here is Q3, okay? So that simply means that force between Q1, Q2, F12 acting vertically, force between Q1 and Q3, that is gonna be F13 acting horizontally, okay? So which simply means that F12, F13, okay, are perpendicular forces whose resultant can be evaluated. Of course, you know how we find resultant of two forces perpendicular to each other, okay, by applying Pythagoras rule. So that means the the resultant force on Q1, which is F1, is gonna be the sum of F12 and F13, but we are gonna apply, we use Pythagoras rule to solve it. Why? Because they are perpendicular to each other. And of course, after you find it, you also need to get the direction, okay? The direction of the force F1, which is the resultant, and that direction is theta. But first, let's get the resultant. So the force on F1, okay, on Q1 is gonna be equal to, okay, the the sum of the vertical force, which of course is F12, then you have to square it according to Pythagoras rule. Then of course F13, you have to square it. And that angle, the direction of this of the F1 is also gotten by, okay, evaluating the tan inverse of the vertical force, which is F12 divided by the horizontal force F13. All right, but first let's get the resultant in magnitude first. All right, so let's get F12, the force. You know very well that F12, okay, is going to be KQ1, Q2, then divided by R12 all squared. So this is going to be equal to, this is going to be 9 times 10 raised to the power of 9. And of course, my Q1 is 1 times 10 raised to the power of minus 6. My Q2 is 2 times 10 raised to the power of minus 6. All divided by the distance. The distance is 10 cm. That's gonna be 0.1 square. All right, so let's get that done. So that's gonna be 18 divided by 0.2. So that should give me 1.8. I've done this before. 1.8 Newton. Then let's evaluate F13. For F13, I'm having, okay, 9 times 10 raised to the power of 9 times, okay, Q1, which of course 1 times 10 raised to the power of minus 6, then Q3 this time, that's going to be 4 times 10 raised to the power of minus 6, then divided by that distance. The distance is 20 cm, and of course 20 cm, let's divide that. Okay, so what do we have? Convert that to meter, that's going to be 0.2 square. Here we go. So I'm having F12 is going to be equal to 9 times 4. Let's get a calculator. 9 times 4, I have 36. Then of course 0.2 squared is 0.04. All right, 0.04, 900. And of course 900 divided by 1000, so I'll end up having 0.9 Newton. Okay, so now let's get our resultant. Don't forget F1 is going to be equal to the square root of F1 2 square, which of course F13, please, this F13, what I just did is F13, okay? F12 square, and of course my F12 is 1.8. I'm having 1.8. Then don't forget you gotta square that. Then plus 0.9, you have to square that also. So let's do that squared. 1.8 square, what do we have? 3.24. Okay, so this is gonna be square root of 3.24, then plus this should be 8 0.81. Okay, if I'm not mistaken. 0.9 square, 0.81. So if I should add that, of course, I will end up having 4.05, the square root of 4.05. So, having gotten that particular the square root, okay, so if I should evaluate the square root, of course, I should have approximately 2 Newton, okay. So the resultant force on Q1 is 2 Newton. All right, and the direction theta is gotten by finding the tan inverse of F12, which of course is 1.8, then divided by F13, that is 0.9. Okay, so let's get that done. 1.8 divided by 0.9, what do we have? That's 2. So I'll end up having theta to be equal to the tan inverse of 2. Tan inverse of 2. So inverse tan of 2. Let's see what we got. So approximately 63 degrees. 63 degrees. Okay. So that is how we apply principle of superposition, right? So I hope that's well understood. Okay. So we're gonna look at electric field in the next video. Okay, see you in the next video. Thank you very much.